All right, so good morning, class. We were supposed to have had our lecture early in the morning, but I was having issues with the internet, so I decided to just have a recorded version and share with you. Last week, Monday, we met in class, and I was telling you that we were going to have a course Bio 300, which is water and wastewater management. My name is Professor Samuel Jesse, and I'm a professor in microbiology and global health. So, as we normally do, this will be the outline of the lecture that we would be having. We have the course in two parts. So we have water and water treatment, and then wastewater and wastewater treatment. For the first part of the lecture, I'll be looking at water. So we'll be looking at water quality, sources of water, how water is used. Then we try to understand the water cycle, water pollution, the effect of this water pollution, how this pollution can be prevented or otherwise controlled, some facts about water pollution, Safe Drinking Water Act. Then we look at the water treatment itself, where we define certain technologies. We will try to understand the goals of water treatment, stages involved in water treatment, that is water that gets into our homes, where we'll be looking at the pre-treatment, coagulation and flocculation, sedimentation, filtration, disinfection, corrosion, and taste and odor control. The second part, like I said, will be wastewater treatment, and that will also follow these thematic areas. So we're looking at wastewater treatment, where we understand some definitions. Also try to understand contaminants in wastewater. We will try to dissect stages in wastewater treatment, where we will dive deeper into pre-treatment, primary treatment, secondary treatment, tertiary treatment, and slag formation. So water. I believe water is so common to all of us. Every day we take in water. When you wake up in the morning, the first thing you do is that you wash your face with water. Some would want to drink water, whether cold or warm. But the fact still remains that water forms the bigger part of our body. And we use some for bathing, for washing, and for other genital purposes. Properties of water, as we say, are often colorless. They have no odor. They also don't have taste. We are saying water has a molecular component consisting of two atoms of hydrogen and one atom of oxygen all put together. But these atoms, as we may get to know, are joined together by covalent molecules. So the slide you see here is a slide of a young girl trying to sip in the priceless water. The one on the left is droplets of water. So we say the earth is covered by more than 236 trillion gallons of water. And that amounts to about 71% of the water in the earth's surface. But suffice to know that although we have plenty sources of water, not all these water are accessible to us. Majority of them are salty, leaving us with only 3% being fresh. But then out of these 3%, 87 of these are still not accessible, with 13% being accessible. That constitutes about 0.04% of all the water sources that we see. So we say because this water is not accessible, they are believed to have locked up in glaciers and other polar caps. Today, research is telling us that more than 2 billion people are affected by water shortages in over 40 countries. Now, out of this, a small proportion of this constitute groundwater and surface water that are clean, and all efforts must be put in place to ensure that they are protected and they remain potable for use. So the slide you see here are water that are locked up in glaciers and in polar ice caps. Let's look at the sources of water that we have. So sources of water are primarily divided into two main groups. We have the surface water, which is direct sources, and then the groundwater, which is the indirect sources. So the surface water consists of the rivers, lakes, reservoirs, and streams. Whereas the groundwater are made up of the aquifers that can either be confined or confined. And these are pictures of these sources of water that I spoke about. Now, in a typical ecosystem, when you take a pictorial view, and if sections of the earth is cut, you would realize that this is how the water landscape looks like. So there are foliages that happens to be on top of mountains. When rain falls on these foliages, they move straight into streams. And these streams flow to water table level. And this is where different sources of water are abstracted. Some are abstracted using hand-dug wells. Others are abstracted using boreholes. Others are also abstracted using artisanal mines. And the list continues. So let us compare the different water sources, surfaces, as compared to the groundwater. For surface water, we say their composition varies. Their mineral content are very low. They are very high in turbidity. Because they are also surface, they have high dissolved oxygen, making it possible for fish to dwell in these water bodies. But then their hardness is also low. Compared to the groundwater, which consists of a constant composition with high mineral content, because they are always correct, turbidities are low, but they have low or no dissolved oxygen with relatively high hardness. So as we said, water are being used for a lot of purposes. The water can be used for agricultural purposes, where they can be used for irrigation, livestock rearing, and fisheries. Some are used for domestic bathing and washing. Some also used for industrial purposes. Other commercial use include use of water in generating hydroelectric power, some for navigation, some also for recreation, that is swimming and bathing, and some are also used to conserve the environment in the form of wildlife and natural resource conservation. So these are some pictorial uses of water that are so common to us that we see on a daily basis. Water cycle. So a question can easily be asked: if water is being used on constant basis, why is it that most of the time the water don't get depleted? It doesn't get depleted because there's what's called the water cycle. Normally, green plants supposed to synthesize, and when they do, they transpire. When they transpire, they move droplets of water into the atmosphere. Some also undergo what we call evapotranspiration, and by so doing, they also move in droplets of water into the atmosphere. When these droplets of water become very heavy, they fall as rain, and they can fall either directly into the streams and oceans, or they can form on the ground and then they can move through seepage. The ones that are in streams and seas can also go to evaporation, where clouds are formed into the atmosphere, and the list continues. Now, if water is so important, then it must not be polluted. If your water is polluted, then it means its natural causes has been impaired. Therefore, if you say water pollution, what we mean is that the water is simply contaminated. Substances that are known to contaminate this water are known as pollutants. And these pollutants are mostly of biological or chemical sources. These pollutants come from homes, farms, industries, and even artisanal small-scale miners. Water pollution makes water unsafe for human consumption, as it leads to a lot of negative health effects. So when water becomes polluted, it leads to manifestation of diseases such as typhoid, cholera, gastroenteritis, and the list continues. The ecosystem is destroyed. It leads to the formation of algal bloom through eutrophication. There is destruction of food chain, and this can also destroy both aquatic and terrestrial lives. These are pictures of negative effects of pollution that must be avoided at all costs. How can you prevent water or control water pollution? It's very simple. We need to control them through education. We must also control them by enforcement of water pollution laws. Now, if water must not be polluted, there are some facts that we must also know about water and how it deals with pollution. It's been reported that over 2 million tons per day of human excreta are deposited directly into water bodies, and this is a matter of concern. Now, we are saying half the population of developing countries are also overexposed to pollution sources of water, and this increases disease. Now, water pollution is capable of killing about 3.6 people every year, and such statistics are really scary. Plastics and water pollution are also known to kill more than 1 million seabirds and over 1,000 marine mammals every year. In fact, it's also true that in every 8 seconds, a child out of 5 dies from water-related diseases through contamination, with around 70% of industrial waste being dumped into these water bodies. And so there is what we want to move towards to safe drinking water. And this is a law that ensures that safe drinking water is available for the public. And for it to be maintained, it requires the Environmental Protection Agency, who needs to establish both primary and secondary drinking water standards. So we are saying primary drinking water standard must be legally enforced, although we can be a little bit reluctant when it comes to secondary drinking water standard, as they may not lead to direct or very serious health consequences. Water quality. So water quality simply means how we determine the quality of water that we have. And to be able to do that, there are about 4 parameters that we must look at. And these parameters are physical characteristics, chemical characteristics, biological characteristics, and even radiological characteristics. And water that is safe for drinking must pass all these 4 categories of water treatment tests. Now, how do we determine physical characteristics? Assuming I have a bottle of water in a bottle and I want to determine its quality, I can determine its quality based on physical characteristics. So by physical characteristics, I look at its temperature, turbidity, taste, odor, and color. So the water that is meant not to have poor physical characteristics must not have temperatures that are so different from the receiving water bodies where the water will be disposed of. The same for turbidity. Turbidity simply means the amount of dirt that appears on the surface of water body. If you say a water body is turbid, then it means it's not clear enough. You cannot possibly see through a water body that is turbid, it means it's polluted. It must not impact any taste. It must not have any color. Neither must it have any odor. And there are specific instruments that are used for determining these physical properties. And they are not magical. So we'll try and see whether we can have some lab sessions where we will have water and try to see how we can determine the physical properties. The chemical properties. We can also determine the pollution of water with regards to its chemical content, where we are interested in the inorganic content of the given water. Then the pH, which means how acidic or how basic that water is, its hardness, the presence or absence of dissolved oxygen, and even dissolved solids. Other parameters may also include metals that include iron, zinc, and lead. There is also inorganics such as fluoride, sulfate, and chlorine. There is also organics such as trihalothane, vinyl chloride, and the list continues. And we may end it with the biological characteristics, which has to do with the presence of microorganisms that could and should not be inside the water. Biological characteristics normally include coliform bacteria, viruses, protozoa, helminths, which must all be absent. And these are some pictures of some biological organisms that may not be present in the given body. Then there is radiological characteristics where we are looking for the presence of the absence of radium, uranium, and plutonium. And all of these have carcinogenic properties on water, which could also impact negatively on the living systems once water containing these elements are consumed. WHO gives standards, and these are given figures upon which values that we compare must meet. So this is all we will have to do for today's lecture. And I have had to go on very fast because it is an online lecture and then you will not have the chance to also ask questions. Next week, Monday, when we meet in person, I'll try and go over. And if there's more questions that need or more explanation that needs to be done, I will explain. All right. Bye-bye.